Everyone, welcome to Adam. Now we are going to solve this question where we are asked to calculate the specific enthalpy, volume, and entropy of the superheated steam at a 15 bar and 220 degrees Celsius. So we have that the volume of water may be neglected and the specific heat of superheated like the steam, there should be steam here equal to 2.2 kg per kilo. So we'll just first write the given data. We have steam at the rate 15 bar and 220 degrees Celsius, which we will convert into Kelvin. So it will be 493 Kelvin. So it does not matter because the difference would be again the degrees difference and the Kelvin difference is the same, but it will make a difference if you have an equation where the only one temperature is needed, such as the ratio of temperature on. So it is always better to convert that into temperature in Kelvin only, and not to remain it in degree. We have for 15 bar pressure the following values, which is Vg, HF, HFG, SFG, and T saturation. So T saturation we will again convert this into a Kelvin value, which is 273 plus 198.3, which will give you 471.3 Kelvin as your T saturation. So as you have all of these values, you can just solve for the question. We want to determine the specific enthalpy for the superheated steam. So we can just solve for first thing, which is a specific enthalpy. If you know the relations of specific enthalpy for superheated fuel or superheated steam, it will be very easy to find out. And the relation is nothing but H2 minus H1 should be equal to Cp into delta T, which is nothing but T2 minus Tn. So this comes from the first law of thermodynamics, and which can be used to derive this equation. So this basically means that how much energy you need to supply for a steam to go from T2 to T1. So that will be the difference between enthalpy. So enthalpy is nothing but the total energy of the system, which contains internal energy and the pressure into volume energy also. So the entire energy change, enthalpy change will be equal to Cp into delta T. So this is the equation which can be derived from the first law of thermodynamics also. And if you have put the point 2 as whatever you want to calculate, which is nothing but T 493 Kelvin, we need to find at that temperature and 50 bar only. So the pressure is constant. That is why we have Cp. So we have H2 minus H1, which will be let us say H minus H at the saturation point. So at the saturation point we have Hg. So we need to find Hg. So we have HF, we have HFG. We can find Hg as HF plus x into HFG and put just x into 1 because it is a saturated steam. It is not it is a dry steam. So if you calculate this, you will get something as 844.7 plus 1945.2. So you can just put it here. 844.7 plus 1945.2 is equal to Cp is given in the question as 2.2. That's 2.2 kilojoule per kg Kelvin into T2 will be the next temperature, which is 493, which is the superheated temperature, minus 471.3, which is your saturation temperature. So if you calculate this, your H comes out to be 2837.64 kilojoule per kg. So this is how you can calculate your specific enthalpy from this very simple equation. In the second thing, which we are going to calculate is volume. So let's see how we can calculate the volume, which we, if you consider the saturated superheated steam as a ideal gas, you can solve this very easily. So you can actually consider it as an ideal gas because there will be no water droplets in it, or the dryness fraction will be 1 for that steam. So superheated steam can be usually considered as an ideal gas. for which for a constant pressure ideal gas, you know that the equation will be like the T2. Let's say for process to 1 we are applying the equation, we have T2 by V2 will be equal to T1 by V1, and we know that because of this ideal gas equation, which is a PV is equal to RT. So if the pressure remains constant, T by V will remain constant. So we have let's say we are calculating now at that the point which we are want to calculate, which is T super heated and T saturated. So T superheated by V superheated, we have T saturated divided by V saturated. So let us just calculate the V superheated. We had T superheated divided by T saturated into V saturated. So we have T superheated as 473 and we have T saturated as 471.3, 493 actually, yeah, 493 we have T2 V saturated, which is okay, which is not given in the equation with yeah, it is given. So this is Vg 0.132 meter cube per kg. So if you 0.132, then you will get the answer as 0.138. This the unit will be the same meter cube per kg. So to now solve further for the third thing which we want to like calculate here, which is nothing but the entropy of the system. So for entropy, the again you need to apply the laws of thermodynamics to like derive a certain equation. I will just write the equation here, which is S2 minus S1 is nothing but Cp into ln of T2 by T1 minus R of ln of P2 by P1. Yeah, this is the for constant pressure. This is the equation. So this one, the first term represents the constant pressure term, and the second term represents the change in pressure if it happens. So if the pressure is constant, this term just becomes zero. So you can just ignore this, and only thing that will remain is just to minus S1 is Cp into delta T. Ln T2 by T. So we can calculate S2, which is at super saturated, as S1, which is S saturated. Let us say plus Cp, which is 2.2 into ln of T2 by 2, which is 493 divided by 471.3. Yeah, 3. So if you like calculate this, you need to first calculate this as so saturated. So what is that? So at the saturated like thing, we have again Sg, which is the saturated C. We have Sl for liquid plus X into SFG. So for fuel, SF plus X into SFG. So this should be S into F, SF. So this is how you can calculate for Sg, which you will go here for X is equal to 1, and the SF and SFG value is given in the in the question. It is given that SFG is 4.12 and SF is 2.314. So just add both of these and put this here. You will get the Sg value, and you will put into this SAT and 2.2 into ln 493 by 471.3. The answer comes out to be 6.5391 kilojoule per kg Kelvin. So this is how you can solve this question. So in some things like became important from this question. First thing will be this equation. Second is this equation. Yeah. So these are things, and the third will also with of course the gases like ideal gas equation also. So these three things you should remember from this question. If this question comes out like again, you can solve this using these three things if you remember these three things. Thank you.